So as soon as we do them, I post them. So we're on Chapter 2, Section 5, Basic Differentiation Properties. So here's the nice part about finally getting to 2.5. Everything we've been doing is kind of set up to get us to this point. And now we can talk about the shortcut. So where we left off last class was, I said if you had the original function, 16x squared, that tells me how many feet the ball fell from the top of the Tower of Pisa. To find how fast the ball is traveling at every single second, then we have to take the derivative. This is the definition of a derivative. Limit as h approaches 0, f of x plus h minus f of x over h. And then we did all this work to get an answer of 32x. So all that work got you 32x. A lot of work. Then we did another one where we said, let's say it was a similar problem, but if we started out with f of x equals negative 16x squared plus 80x plus 6, using the definition of a derivative, what's the derivative function? We did all this work, all this algebra stuff, all this work, full page to get negative 32x plus 8. Okay? Because we did all the work, we spent all the time on limits, we spent all the time on the algebra, now you get the benefit. The benefit is the shortcut. Okay? So before we actually jump into the lesson, let me kind of give you a brief introduction to the shortcut. How can I find the derivative quickly? Well, again, if you have f of x equals 16x squared, this is the actual work to get 32x. Are we okay? But here's the shortcut. Don't blink, because it's that quick. So this is my original function, f of x. The derivative function will be f prime of x. How do you find the derivative quickly? Ready? 2 times 16. What's 2 times 16? 32. Then always subtract 1. What's 2 minus 1? Done. Would you rather do all of this? Or would you rather do that? That. And that's it. That's what we're going to focus on today. The hard part is not doing the shortcut. The hard part is what does it mean? How can we use it? That's what this class is all about. Okay? Another one real quick. We did negative 16x squared plus 80x plus 6. To find the derivative, we would have to do all of this work, and we would end up with negative 32x plus 80. Well, if we use our shortcut formula, we can find the derivative of each one slowly. What's 2 times negative 16? Negative 32. Subtract 1. What's 2 minus 1? Stop there. Any questions there? Now, 80x is really 80x to the 1. Are we okay with that? What's 1 times 80? And then we subtract 1. What's 1 minus 1? So no more x. Then, what's the derivative of 6? The derivative of 6 is 0. The derivative of any number is 0. Why? The reason why is, do you see a variable here? No. But if there was a variable, it would be x to the 0. And what's 0 times 6? 0. Okay? So the derivative of any number is 0. So let's do some quick ones. Then we'll jump to the formal notes. So if I had x to the 12, what would be the derivative of x to the 12? The 12 would go in front, because there's a 1 here. 12 times 1 is 12. And then what do you always do? Subtract 1, you get 11. That's it. Don't overcomplicate it. Don't make it harder than it is. And why does it work? If I plugged in x plus h to the 12th power, that thing 12 times minus the original divided by h, blah, 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 that's what you get. You don't want to do all that work, trust me. Are we okay? Now, what if I said, what's the derivative of 3x to the 7? What if I said, what's the derivative of 3x to the 7? 7 times 3 is, subtract 1 you get. That's it. Don't complicate it. Don't make it harder than it is. Now, What if I said negative 4x to the negative 7? Oh no, it's a negative. Does it matter? No, it's the same stuff. Negative 4 times negative 7 would be 28. Subtract 1, be careful, what do you get? Negative 8. Okay, there's where you're going to make your mistakes. It's not anything to do with calculus. And then if it was me, I always rewrite negative exponents to positive exponents. Move it to the bottom. Okay, what if I had 2x to the 0.7? Oh no, it's a decimal. Does it matter? No. So this would be 2 times 0.7 is 1.4. Subtract 1, be careful. What's 0.7 minus 1? Do you need your calculator for that? What? What? 0.7 minus 1. Negative 0.3. Thank you. And then again, I like to write negative exponents as positive by bringing them down. Okay? So it doesn't matter if it's a negative, doesn't matter if it's a decimal, doesn't matter if it's a fraction. No. Okay? I'm going to do one more, well, a couple more, then we'll jump to the notes. What if I had 4x to the 2/3 minus 7x plus 3? Oh no, there's a fraction. Does it matter? No. If you're bad at fractions, you're going to have to work on it, use your calculator. 4 times 2/3 is actually 8/3. What's 2/3 minus 1? The problem is not calculus. The problem is fractions. The problem is decimals. That's where we come into a lot of issues, is that it has nothing to do with the calculus part. It's the basics that I have trouble with. Does anybody know what that is? 2/3 minus 1? Negative 1/3. Now, let me just emphasize these again. What's the derivative of negative 7x? If you have to go through your steps, there's a 1 here. What's 1 times 7? 7, so I put minus 7. But then 1 minus 1 is 0. So what happens to the x? So can we find a better shortcut? What's the derivative of 10x? 10. What's the derivative of 7x? 7. What's the derivative of 100x? 100. Because you know why, if it's just the number in front of x, the derivative becomes the number in front. You know why. And what's the derivative of 3? 0. What's the derivative of any number? See how we're getting faster already? You should understand the why. X to the 0, 0 times 3, 0. Understand the why, but now we can get faster. Are we okay? The last one I want to talk about, and then we'll do the notes, which is going to just review all this, is what if I had 1 over x to the 3rd? Now we're like, oh, you've killed me now. I thought life was going to be easy. I know there's going to be decimals and I know there's going to be fractions. But what do I do about this? What you need to understand is you love when it's a number, an exponent, number in front, variable, exponent goes to the front. You can do those all day. So if it doesn't look like that, step 1 is to rewrite it. Not to take the derivative, rewrite it first. How can I rewrite 1 over x to the 3rd so the x to the 3rd is not on the bottom? I'm not taking the derivative. And this is where notation comes in. I'm not taking the derivative yet. Derivative is when I have a little prime. How can I rewrite this? Perfect. X to the negative 3. So if it looks awkward or difficult, you may need to simplify or clean it up first. That's why we spend so much time on algebra. If you don't know why 1 over x to the 3rd is x to the negative 3, that's all the stuff from before. Okay? That's where we're going to struggle. Not with the calculus, with your algebra. Then the derivative. Now please notice what I'm doing on purpose. Here's the function. Here's the rewrite of the function. Is this the derivative? No. And it's not. Doesn't have a prime. It's not the derivative. This is the derivative. What would the derivative be? Negative 3 goes in front. X to the negative 4. And then I would put the negative 4 on the bottom, make it a positive 4. That would be your final answer. Okay? That's pretty much today's lesson. The how to. Then we're going to use it. But people get caught up in the decimals, the fractions, the negatives, the stuff that you shouldn't get caught up on. Okay? So back to the notes. So I already kind of explained to you from the definition is where we can get the derivative. I explained the notation, f prime. You've also seen dy over dx or d over dx of the function. All means derivative, different ways of writing it. The derivative of any number is 0. We'll talk about the y. So even if the number looks kind of weird, what's pi? 3.14 da 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 da. It's just a number. So pi squared times 10. What's the derivative of all of this? All of this is just a number. What's the derivative? What's the derivative of any number?
0.
0. So what's the derivative of this? 0, because it's just a number. Pi is a number squared, number squared. It's all just a number. Okay? The derivative is 0. And then we already talked about the exponent goes to the front, subtract 1. The exponent goes to the front, subtract 1. That's theorem 2 power rule. So if you want to find the derivative of x to the 6, what's the derivative of x to the 6? 6x to the 5th. Oh. We okay? Calculus just got a whole lot easier, right? But it's not how to do it. We talked about that. It's why we do it is what we're going to focus on. Okay? So for practice, go ahead and do this one. It should look familiar. Find the derivative of 1 over x to the 5th. So if it doesn't look like number in front, variable, exponent, step 1 will be to rewrite it. So how can I rewrite 1 over x to the 5th? X to the negative 5. So the derivative, notice the difference, original derivative, what would the derivative be? Negative 5x to the, please be careful, negative 6. Negative 5 minus 1 is negative 6, not 4. And then I like to make sure my exponents are positives. It's just easier to plug in later. That would be your answer. Are we okay? Now remember, if it looks awkward, rewrite it first. If it looks awkward, rewrite it first. So our answer will be negative 5 over x to the 6. Try this one. And again, if it looks awkward, step 1 is to rewrite it. The question is, do you know how to rewrite it? Algebra, 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 algebra. That's why I told you on day 1, it's not the calculus that's going to hurt you. It's the algebra. Calculus is new for everybody. So if you write it first, take the derivative. Okay, so if we're a little stuck, I hope we're not, but if we are, how do we rewrite the 4th root of x to the 3rd? X to the 3/4. If you forgot that, now you know. So if it's on a test or something like that, you're able to do it. Now take the derivative. Yes, it's a fraction. Oh no, oh my gosh, it's a fraction. You'll survive. You need to know how to be fractions. Okay, so the derivative, the 3/4 will go to the front. What's 3/4 minus 1? Negative 1/4. Now, here's how I would rewrite it. 3 over 4x to the 1/4. That's how I would write it. Anytime you have a negative exponent, I like to make them positive. Now, if you're wondering, why does he do that? Why does he do the extra work? Okay, let me do a little side note. Without thinking, just quickly, what's 3 squared? Don't think, what is it? 3 squared? 9. Just like that, 3 squared is 9. Everyone in the room is good? Okay? Quick, without thinking, what's 3 to the negative 2? Well, watch. If you rewrite it, isn't that 1 over 3 squared? And what's 1 over 3 squared? 1 over 9. Okay? So, looking like this, 3 to the negative 2, you're not sure what that means. But if you rewrite it, you can do it quickly, 1 over 9. So we prefer positive exponents. We're comfortable with negative exponents. So I always like the end, make them positive. Okay? But they rewrote it as 3 over 4 to the 4th root of x, same thing. Okay? Now, we've already gone over this, but this is basically saying if you have a number in front, what do you do to the number in front? We multiply it. You can kind of pull that constant out and then take the derivative and then multiply the coefficients. Bottom line is, what's the derivative of 12x to the 4? What's the derivative of 12x to the 4? 48x to the 3rd. So if there's a number in front, 4 times 12 is 48. Subtract 1, x to the 3rd. Okay? So the number in front should throw us off. And if I have things that are being added or subtracted, you just take the derivative of each one. If you have things that are being added or subtracted, you take the derivative of each one. So on your paper now, take the derivative of 3x to the 3rd plus 11x squared. So bottom line, I have 2 things that are being added, take the derivative of each one. I have 2 things that are being added, you simply take the derivative of each one. Okay, so what's the derivative of 3x to the 3rd? 9x squared. What's the derivative of 11x squared? 22x. Okay, so again, make sure your notation is correct. F prime of x is the derivative, that's the original 9x squared plus 22x. Okay? Now, let's look at this one. I'm going to write it on the paper. If we had 3 minus x to the 3rd over x to the 6th, okay? Right now you're looking at it saying, whoa, we just jumped to a super hard one, okay? And I'm going to say, if it looks awkward or weird, what should you do first? Rewrite. That's it. So, not the derivative, but I'm just rewriting the original. What's being divided by x to the 6th? The first, second, or both? What's being divided by x to the 6th? The 3, the x to the 3rd, both, 1? Both of them. So I'm going to write that. 3 over x to the 6th minus x to the 3rd, x to the 6th. So just rewriting it, not taking the derivative, just rewriting it. Then, can we clean this up a little bit? Well, remember, if I have to take the derivative, I don't want the exponent on the bottom. So that would be 3x to the negative 6. Does that look like something I can take the derivative of pretty easily? And x to the 3rd over x to the 6th, that becomes what? X to the negative 3. Okay? If this is, again, this is algebra. This could be looked at as 1 over x to the third, which is x to the -3. That's the problem we're going to have. It's not the calculus. It's algebra, algebra, algebra. And if you're really lost, this is 3 x's on top, 1, 2, 3, 4, 5, 6 x's on the bottom. You're left with 3 x's on the bottom, however you want to look at it. But you got to know that stuff. Okay? So now that I've cleaned it up, now take the derivative. Okay? So it's the algebra that's going to get us every time. Now you have to know your exponents. Okay, so if we took the derivative, 3 times -6 is -18, x to the -7. -3 times negative will be +3, x to the -4. And then I would rewrite it as -18 over x to the 7 plus 3 over x to the 4. Are we okay? Hopefully we're looking at this saying it's not too bad, it's not too bad. But the big question you should be asking is, why are we doing this? What's the point? I can do this all day, but why do we do this? What's the point of derivatives? That's an amazing question. That's what I need to answer. Okay? So, and you'll see that in the notes, they wrote it the same way, but then they kind of combined it at the end. It's the same. It's the same. Okay? So let's work on a work problem. An object moves along the y-axis so that its position at time x is the function x to the third minus 6x squared plus 9x. Find the instantaneous velocity function v. Okay, so let's kind of take this down nice and slow. Okay? So we're given the function f of x equals x to the third minus 6x squared plus 9x. Okay? But if we don't know what that means, then there's no point. Okay? So x is seconds, and f of x is the position in feet. Okay? So anytime we have a word problem, step 1 is to make sure we understand what everything is. Okay? So you plug in 2 seconds, and it will tell you how many feet you've gone. You plug in 4 seconds, it tells you how many feet you've gone. That's great. What I want to do is find the velocity. Okay? And what is velocity? Velocity is the derivative. Okay? Because what is the derivative? Rate of change. It's not feet, it's going to be feet per second. How the position is changing. So take the derivative. Now, if we take the derivative, what's the derivative of x to the third? 3x squared. What's the derivative of negative 6x squared? And what's the derivative of plus 9x? Stop there. Now, let's make sure we understand the difference. If I plug into the original, you tell me how many seconds? What comes out is the feet. In the derivative, your input is still seconds, but your output is not feet, it's feet per second. It's how the feet is changing. It's velocity. Velocity. Okay? So you'll notice that f prime of x is also called v of x because v is for velocity. V is for velocity. Okay? So what's the point in this? Okay? So again, in the notes, they got 3x squared minus 12x plus 9. We want to find the velocity at 2 seconds and 5 seconds. And I'm going to take this even further. We're going to find the velocity and the position at 2 seconds and 5 seconds. Okay? So we want to know when x is 2 and when x is 5. Okay? Now, I think it's clear that if I want to know the position at 2, I would plug into the original. And if I want to know the velocity at 2, I would plug it into the velocity function. And the same thing goes for 5. Now I'm showing all my work to show you where everything goes, so the answer just doesn't show up from magic. And what I'm really concerned with is what this all means. Okay, so I'm showing all my work on purpose. Okay, the first one is plugging into the original. The second one's plugging into the derivative. I plugged in 2 seconds, and I plugged in 5 seconds. Now, I could just type all that in. But I'm a little lazy. And I taught you all how to use the calculator, so shouldn't we use the calculator? Okay, so what's going to go in y1? The original or the derivative? The original. What's going to go in y2? The derivative. So let's go to our calculator. In y1, we're going to put the original. In y2, we're going to put the derivative. Okay? So I'm going to go to my calculator. I go to y equals, make sure that your plots are off. I go to the top. Make sure all these are not highlighted. In y1, I put x raised to the third over minus 6x squared plus 9x. And then in y2, I put 3x squared minus 12x plus 9. Okay? So in y1, I have the original. And in y2, I have the derivative. Are we okay? Then go to the table feature, plug in 2, plug in 5. So then I go to second graph for the table, plug in 2, plug in 5. Are we all getting the same answers? Now, if you're not able to plug in 2 and not able to plug in 5, again, you got to make sure your table's set. Second window, make sure it's Ask Auto. Second window, make sure it's Ask Auto. We already set the table. We can't set it every single class. So you have to set it and keep it. If you're borrowing a calculator every week, which is fine, just make sure you go to second window, make sure it's Ask Auto. So when you go to second graph for the table, you can plug in 2 and 5. Is everybody getting the same answers? Same answers? So when I plug in 2, I get 2 and I get -3. When I plug in 5, I get 20 and I get 24. Okay? This tells me feet. This tells me feet per second. This tells me feet. This tells me feet per second. Now, what if I did the derivative wrong? If I did the derivative wrong, could that mess up everything? Wouldn't it be nice if the calculator could check my derivative? You think it can? It's better for $100, right? So let's have the calculator check. So everyone go to your calculator, go to y equals. y1 is the original, that tells me feet. y2 is the derivative, that tells me feet per second. Everyone go to y3. Everyone go to y3, and I want you to write these steps down. Okay? On y3, we're going to push math. Math is all the way on the left. Math. Everybody see this? Okay. After pushing math, I want you to go down to number 8. What does number 8 say? And derivative, which basically means derivative. Okay? So choose number 8. And then if your calculator looks like mine, d over d something, 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 then I'm going to teach you how to do it. If your calculator says n derivative is blinking, I'll show you that too. Okay? So if your calculator looks like mine, the first thing you have to put in is an x, because you're taking the derivative with respect to x. And then the next thing you have to plug in is, what are you taking the derivative of? You're taking the derivative of the original, right? Where's the original? y1. So how do you tell the calculator y1? Write down the steps. Vars. Everyone push vars. It's on the top right. Then push to the right for y vars. Push to the right for y bars. Push number 1 for function. Push number 1 for function. And then where's the original? Choose y1. Choose number 1, and it puts y1 there. Now, then there's still one more blank. Push to the right, and the last blank is an x. So it's x, y1, x. Now, if you have the other version of the calculator, which is totally fine, no problem at all, the way you type it in is you're going to hit math 8, but it's blinking. You're going to put vars, y vars, function, y1 first. So it's y1 first, comma, above the 7, x, comma, x, close parentheses. So you're still putting in 2 x's and a y1. You're just doing it in a different order. Okay? Now you're like, that's a lot of steps. What's the point? Well, the point is, when I go to the table, which ones should match? y1, y2, y3. Which should match? Which should match? Move over, move over, move over. Which one should match? y2 and y3. y2 is my derivative by hand. y2 is the derivative in the calculator. If they don't match, something went wrong. We okay? So does anybody's calculator not match? Does anybody's calculator not match? Okay? So, in addition to being able to check your work, what does all this mean? What does all this mean? So if I go back to the notes real quick, when you plug in 2 into the velocity, it says the instantaneous velocity at 2 seconds is -3 feet per second. That means it's going downward. Negative means downward. And if we plug in 5, you get 24. That means the instantaneous velocity at 5 seconds is 24 feet per second. So if I could freeze time at 5 seconds, how fast is it moving? 24 feet per second. Okay? So the y is, I know you're worried about the details and the calculator and the buttons, but I'm worried about what this stuff means. Okay? Questions? So, find the time when the velocity is 0. Okay? So, there's the velocity. Set it equal to 0. And we're going to do this together. So I'll kind of explain the notes. If I was going to solve when the velocity is 0, what would you do first? Factor out of 3. Then what would you do? You have x squared minus 4x plus 3. What would you do? Algebra, algebra, algebra. It would be x minus 3, x minus 1. So you factor further. Then, what solutions would you get? 1 and 3. Okay? So again, if you're struggling because of algebra. You're not struggling because of calculus right now. If you're having issues with factoring. That's Appendix A, Chapter 1. That's why we spend so much time on it. Okay? So if I want to know when is the velocity equal 0, it happens at 1 second, it happens at 3 seconds. So when is velocity 0? What does that mean? If your car was going 0 miles per hour, what does that mean? It's not going, right? So 1 second and 3 seconds is probably where it started and where it ended. It's not moving. Okay? So everything has meaning. But again, if you're struggling because of algebra, not the derivative, algebra is where you're struggling. Okay? So the velocity of this object is 0 at 1 and 3 seconds. Okay? So this is equation of a tangent line. I don't want us to stress too much about this one. Understand that the slope of the tangent line is the derivative. Slope of the tangent line is derivative. We use that in applications, but I really want to focus on the derivative. So here's what I want you to do. Step 1, take the derivative. Okay? What's the derivative? 9x squared. Are we okay there? So if we're going to derivative, I'm going to go the rest through the notes. Okay? So step 1, find the derivative. Step 1, find the derivative. Any questions there? Step 2, we know the derivative is 9x squared minus 4x. If I said, find the equation of the tangent line when x equals 1. Find the equation of the tangent line for x equals 1. And this is not something I'm going to stress. So I'm going to go through this a little quickly. I like to stress word problems, which will not really involve it. It involves it in a sense. So if you take 1, plug it into the original, you get 6. Just bear with me, kind of follow along. If I want to find the equation of the tangent line when x equals 1. I take 1, plug it into the original, and I get 6. So I have the point 1, comma 6. I have a point. Now we know to find an equation of a line, if we had a point and a slope, you could find the equation of a line. So we got a point, 1, comma 6. To find the tangent line at 1, comma 6, we find the slope. So to find the slope, you plug 1 into the derivative. To find the slope, you plug 1 into the derivative. To find the slope of the tangent line, the derivative is the slope of the tangent line. So we take that 1, plug it into derivative, and we get 5. This goes back to your algebra. How do you find the equation of a line if you're given a point, 1, comma 6, and the slope, 5? That was in Appendix A and stuff we've covered. In a quick review, if the slope is 5 and the point is 1, comma 6, we can use point slope form. Y minus y1 over m, y minus y1 equals m times x minus x1. We plug in the point, 1 and 6, and we get the equation y equals 5x plus 1. That would be the equation of a line when x is 1. Again, not something I'm going to stress because we're going to be doing application problems with derivatives. This is just reinforcing that remember we said in the beginning that derivative has 2 meanings. One, the tangent line, derivative slope of the tangent line, and then the application problems. We're spending more time on the application problems. This is referencing the tangent line. Okay? So the tangent line, when we found it, y equals 5x plus 1. If I want to find when the values are horizontal is when the slope is 0. I can set it equal to 0. When is the slope 0? Remember, slope is the derivative. Set equal to 0. Again, this will be algebra. Factor out the x. get two answers. The tangent line of the function is horizontal at either 0 and 4 over 9. Again, not a major focus for us because we're doing application problems. But understanding that the derivative is the slope of the tangent line, horizontal is on the slope of 0, and some algebra. Good? Doing all right?